Welcome back, chemistry fans. Okay, let's get into it. Tonight, we're going to talk about Unit 2 exam solutions. So let's do this. Share my screen, and we will start right away. Question number 1, I hope. Yes, question number 1. Let's blow this up. And those are dealing with nomenclature, giving us the name. So sulfur tells us that it is dealing with, or sulfurous tells us that it's dealing with sulfur. What you should have picked up on is the suffix ending OUS, telling you that it has one less oxygen. There was an SO4, there's an SO3, and it has a charge of -2. It would cross over, and it would make 2 of those because hydrogen only has a charge of 1. Vanadium 6 sulfide. So vanadium would have a charge of +6. The silicide would have a charge of -4. You crisscross, you have 4 and 6, but that needs to be reduced down to V2Si3. And we know that because of the Roman numeral transition metals. Rhenium is also a Roman numeral, but in this case, what we're going to do is we're going to cross backwards to find out the charges of these two. So I have rhenium, and the Roman numeral would be 7 because the charge is moving backwards, and carbonate is the name of the polyatomic ion that you don't have to memorize. This is an acid as well. It's a binary acid. The word is arsenic, arsenic. Because it is binary, we have to put a hydro in front as the prefix. So we have hydroarsenic acid. You don't need to double the suffix on that one. If you did, it's still correct for spelling purposes. Okay, now we're jumping into shapes and Lewis structures. All right, so first element listed is P. So it will go in the middle. It does not matter if you want to put your CLs on the side, top and bottom, whatever. We're going to do 1 minus have. The 1 for each one of these is 8. So that's 8 times 4, which is 32. The have on these is going to be a little bit different. Phosphorus has 5. Nitrogen has 5. The chlorines each have 7. So that's 24. Subtract those 2, and we should get 8. Okay. Now, in this, we know that the halogens have single bonds. That means the double bond had to be on the nitrogen. There are no need for extra electrons on the P. So therefore, this one is a trigonal planar. That's a planar. So it's a trigonal planar. Now, as far as the dipole moments are concerned, phosphorus would be larger than the nitrogen, so are the chlorines. Because this lays flat, what we would also have is that the phosphorus would be the largest of the elements as far as the trend is concerned. And so what we would have is all of the charges pointing towards the middle. Because they're all in this looking like this. So they're all equidistant apart. So there's not a shape polarity. It's only based on size. Okay, moving on to another shape question. And this one has a charge upon it. So what we got to do with that is we have to take it into account whenever we have our want minus have. The first element is sulfur. It goes in the middle. Again, the P's on the top, and the O's can be on the side. It doesn't matter. As far as want minus have, there are 4 elements. They each want 8. That is a total of 32. The have starts off with 3 because of that charge. The sulfur and the oxygens each have 6, and the phosphorus has 5. So 18 plus 8 is 26. The difference there is 6, meaning that we're going to have single bonds on each one of these, that the sulfur is in fact going to have extra electrons. That is going to cause repulsion. That is going to cause the molecule to bend downward. This is called a trigonal pyramidal. Now, because of this shape, we have overall and this would be my sulfur up here, we have some overall ideas about the dipole moment. Now, if you want to make it look like we have some size expectations, you could put something along these lines. I would take that as well. That would be perfectly sufficient to have dipole moments pushing in towards the sulfur. Or if you wanted to then have one that went like this, that pushed towards the phosphorus, which was the largest of the elements on this list. However you want to go about it, as long as I saw some kind of a reflection of recognition of the size or shape rather, because it does actually say associated with the shape, not with the size. So it should have been this as the correct answer, but I took whatever you had for the most part and made it work for a correct answer. Which image showed the resonant structure? Well, I should have actually gotten into the test itself. So hold on, let me go back here because some of these are multiple choice. So let me find out what's going on here. The images, resonance needs to have the bond moving from one side to the other. And all of the other images, what we have is are completely different structures, or they haven't moved at all. So we need to find proof that that we have gotten the movement of the double bond from one side to the other. But in all the other examples, what we have here are completely new structures, or they just have flipped sides, but the bonds haven't moved. Now, on the third one, you do see the bond moving, but you also see that there is an OH on the right versus the O on the left. All right. Bond lengths and bond strength, they are inversely proportional. As bond length increases, let me go back to the slides here. As we know, triple bonds are the strongest, but they're also the shortest. So that means that they are in an inverse relationship. As the strength goes up, the length goes down. That means they're inversely proportional. Okay, and then finally, number 9 on this page here, 3 words to describe how bonds can exist. That would be size, shape, or bond is what I was looking for. Electronegativity was fine. Something along with ionic character would have also been fine. Okay, number 10. This one we had to actually use the chart to figure out what were the different types of bonds. So we'd have cesium, oh my gosh, 56, I believe, 55, and it has a 0.79, and oxygen has a 3.44. So after we subtract those two values from one another, 3.44 minus 0.79, we get 2.65. Well, the cutoff is somewhere right around 2. So that means that this one is really, really ionic. That means that this one is really, really polar. Now, the C and the Cl, carbon is 2.55 and the chlorine is 3.16. So if you subtract those two values, 3.16 minus 2.55, you get 0.61, which is somewhere over the difference of 0.4, 0.5. And so that makes this one halfway, and it's called polar covalent. And if we talk about B and H, we have 2.04 and H is 2.2. The difference there is 0.16. And that one means that this one is nonpolar covalent. All right, number 11, 12, and 13. Last questions. And I believe I have to go back to the question, which one has the strongest bonds? Let's see if we can go back to the multiple choice here to figure those out. Strongest bonds happen with the triple bonds. So let's hope that that is one of the choices, and it is. Nitrogen has the triple bond. The double bonds are not. The double bonds are less. The single bonds are less. And then finally, 109, those occur whenever we have a bent molecule or a trigonal pyramid. Now, some of you may have fallen for this one down the bottom, the BF3, but it does not have the extra electron. So it actually lays as a trigonal planar still, just as The third choice did here. The only one that has the extra electrons causing the repulsion, causing it to bend, is the one that is the 109 angle. All right, last question. 2 rational reasons why polarity exists in water. And so needed you to have some rational explanation for it. And it could have been any of the above reasons: size, shape, or bond. Now, if you're going to go with the bond, that means we need to prove it. You can't just say that there was an ionic character. So we would have to have 3.44 for the oxygen and 2.2 for the hydrogen. So 3.44 minus 2.2 is a 1.24. That is somewhere in between. So it's actually polar covalent. But according to all of our discussions that we had in class, if it's just a little bit, so 3.44 minus 2.2 would give me 1.24, which is polar covalent. That's still polar in some extent. So that tells me about it. Now, size, they are on different energy levels. Hydrogen is here, oxygen is here. You needed to make mention of that. You need to tell me something about the trend, not just that one is bigger. Well, what proof do you have? You need to tell me they're on different energy levels. That means their size is different. And then as far as shape is concerned, you can't just tell me, oh, it's bent. We have to have demonstration of the mastery of the content knowledge, want minus have. And so that means 8 for the oxygens and 4 for the hydrogens, which is a total of 12. The have is going to be 6 and 2. That's 8. The difference is 4, meaning there's a single bond, and then you have extra electrons, which cause the repulsion, which causes it to be bent. And bent is polar. All right. So you had to provide proof. It's not just a statement. It needs to tell me why you know that that is true. All right. So with that said, this is everything for the test. Thank you so much. I wish you well on your corrections so that we can improve our demonstration of knowledge. You can't just provide me with answers. You must provide me with proof that you understand it, giving all of the background details, writing the formulas, giving me a depth of knowledge that proves to me that you understand it, that it wasn't just a fluke mistake, that it may have been a silly mistake, but that there is real learning that has been achieved. Thank you so much for your time. Good night. Bye-bye.